Hello folks, and welcome to yet another semi-exciting, probably more boring than exciting episode of Damien Finds Way to Waste Time While on Lockdown. So, let me get this straight out there. Despite the fact that you're going to see some serious Keysight test gear here in this particular episode, I'm not sponsored by Keysight. So, the old caveat done. Now, but what we do have here is, to the best of my knowledge, a rather serious piece of Keysight test gear, which is the MSOS804A Mixed Signals Oscilloscope, for those of you interested in such things. Now, what we are applying its considerably superior intellect than mine to is this Model 3 high voltage controller PCB here. Now this is a board I've had for some time. It was donated to me along with the PCS that we I've got the hardware for the control system done for. I've recently got the PCS installed in the E46 Touring, and then the old crapper virus lockdown started. So hey, you know, gives me time to gives me some more time to waste. So I figured let's have a look at this thing, because I was quite fascinated with some of the information that appeared on EVTV there a few weeks ago. And I thought, well, let's have a look at this and see if I can find anything that might be useful. So obviously I've just got the high voltage controller board here at the minute. Don't have any of the batteries here. I do have a Model 3 battery complete that we are going to have to look at, but I had this high voltage controller PCB here, and I thought, oh well, you know, I've got been working on the drive unit, inverters there, and I just need a break and need to get some digital electronics into my life. Well, yeah, that was a mistake, because this thing is probably more analog than digital. So for those of you that didn't watch the Adam West Batman growing up, if I were to use the phrase bat brains on the boy blunder, you can substitute the Batman and Robin, some kind of battery management ASICs in here instead. Now, I was looking around at this even a few weeks before EVTV published that data, and I came across some information that was purporting to say this was some kind of ISO SPI system, but then I'd noticed a few people had tried communicating with it using some of these, what do they call them? Demo boards, but hadn't been able to do so. Another guy said he had, and la-di-da-di-da. So I thought, okay, well, no, I wasn't going to do much with that immediately, but, you know, now that I have time to waste, let's, you know, look at it now. So, interestingly, there are two ports here on the board. There's a black and a grey 2-pin port. Now, the black port connects to a transformer, little pulse transformer kind of a thing here. And it's connected to Batman. Sorry, can't resist. And this grey port has another pulse transformer and is connected to the boy blunder. Now, they both have these little 6-pin 2.5mm headers there. And I thought, okay, that's interesting. I went probing around there and I started seeing some digital signals. So thought, okay, let's break out the big chief here and see what it can make of it. And I was looking first of all at the, I guess you could call it analog signal, that's on the two headers here. And it's very interesting. I know that's, probably the 10 people that are going to watch this, I've probably lost 11 of them by saying that. But I found this signal for what looks to be very simple. It seems to contain quite a lot of data. Now, I don't know how this is going to turn out on camera. This thing does have VGA ports and all sorts of ways that I could do clever screen capture things, but unfortunately, I don't have the hardware to do anything with that. Story of my life, right? So, let's go have a look here. I'm going to get my face out of the corner of your screen for a minute there. Oops. Yes, my wonderful video processing skills coming to the fore again. I need someone to just do this crap for me. There I go. Now I'm in the part where I shouldn't be blocking your view, hopefully. Let's get you in here a bit tighter. There you go. Alright, so the orange trace that you see here is the Batman output from the pulse transformer. I've got the scope frozen here at the minute. So what you're looking at here is this orange area is the Batman output, and these blue logic analyzer traces are 4 of the 6 digital pins on this little header here. One of them's a ground. One of them seems to have a stable 3.3 volts on that. It could be even a 3.3 volt supply. But 4 of these seem to have some data on them. Now, if we take a bit of a closer look at this, I want to try and get one frame on the screen here for you. And this is where things start getting kind of interesting, because what we have here, this digital 0 here, to the best that I can make out, is a chip select line, because when this goes low, oh really, seriously, stop. This is what happens when you've complicated test gear and a moron working it. So let me use this instead. This D0 looks to be a chip select. D1 is some kind of a data pin. D2 is a data pin, and D3 is a clock, from what I can tell. Now, if we do, let me get you back here. If we do a frequency measurement, both on the analog signal and on the clock signal, we get a 1 megahertz frequency on this thing. Now, this analog signal, you're going to find as we look further into this, seems to be synchronized with the clock pulses. And then I kind of say to myself, well, okay, that's great, but how do they encode data in there? Because this is, only a 2-wire thing. So what I did was, this thing has a protocol decode function on there. So I put it on, as you can see here, SPI 4-wire, signals on digital 1 and 2, clock on 3, and chip select source, digital 0, 8-bit word size and LSB bit order, I guess. Now, I don't know whether that's right or wrong, but it's given me some kind of data here. So we'll kind of go with that for now. So the first thing that we see is that we get 84 4F being decoded on digital 2, and we get 0000 being decoded on digital 1. Now, what we then find is we get a gap, and then we get lots of more of the same thing, and we actually get 8 occurrences of this 84 4F and 00 on the second data line being repeated. So you think, okay, that's fine. There it is. But now things kick up a gear, and we get into quite a busy kind of a data stream here. And we get this. And this is basically B285ED, and then a whole bunch of zeros. Well, these zeros that we see here are, well, they're actually 2 zeros. There's kind of groups, so I'm guessing it's some kind of a 16-bit value going on here. But these are grouped by these pulses on this data line here, and this goes on and on and on and on and on for quite some time. Let's keep going, keep going, keep going. Now, of course, I've got a theory here which is probably completely wrong, okay? And my theory is that this is where we would see the cell data if I had a full battery, or even, I don't know, one module even connected up to this thing. So that is potentially something that we're going, well, hello, Damien, hello. This is something that we're going to need to find out. But I hear you say that's, you know, that's all fascinating. But what are we going to do with this? You know, I don't know. I guess it's kind of a learning process for me. What is it that Kent Brockman said? Is it, you know, could we tell our viewers that it's time to head out and crack open the battery of the Tesla nearest you and feast on the data inside? Well, I think it is. So that's what we're doing. We're feasting on the lack of data inside because they're all zeros. Of course, that would then ask me the question, well, how many of them are there? Because that might be useful. But anyway, so that is a kind of, that's a data burst with a decode set up, as you just saw. Now, what that means, I don't know. But this is Bat Brains, both his analog and digital signals. Now, let's get you down here to have a look-see at something else. Not my foot on the bench, by the way. This thing here is some kind of super weird NXP microcontroller that is obviously some kind of a brain function for the BMS. Now, I was there today, and I'm kind of feeling weird today. Like I don't really want to do anything, and yet I'm compelled to. So, welcome to my life. I wanted to do the trick that I've done with the drive unit and put this thing into reset and see if all of my Batman and Robin data went away. So I go on the NXP website and I try to get a data sheet with an actual pinout for this thing. That is an absolute goddamn nightmare. And I just, you know what? I just gave up. Got myself a multimeter probe and a 1K resistor and just went to town on this thing. And I found something that at least resembles a reset line on this BMS JTAG header here. And this most certainly does close down the operations, both between this chip and this chip. And we lose all SPI communication between BatBrains and the outside world. So all the SPI lines shut down. So all this stuff here goes away. So that would lead me to believe that what we are seeing on the scope, you know, all of this data here that we're seeing is some kind of request by the by that NXP battery management chip to say, hello, cell boards, give me your data, give me your voltages, temperatures, whatever else you may want to have. So, if so, kind of what I'm possibly going to do, well, there's two more things I need to do. I need to do this with the actual cell modules connected up and see if any of this nonsense that I've been just talking about turns out to be true. So do we start seeing cell data here in place of all the zeros, or am I just barking up the absolute wrong tree here? And if that's the case, well, that's really cool, because then I get to go back to square zero and start again, and that'll waste more time. So yay. So that's the first thing to do. Second thing to do is we then knock out the old NXP here, and we start seeing if we can use BatBrains here to talk to his crime-fighting friends on the BMS board and see if we can extract some data from them. There's also some kind of SPI shunt on here, so we can have some fun with that. And Super Scope here will be useful in the working out all of that data. I've never had anything like this before. I mean, this thing is crazy. My only criticism, right, is that this thing runs on Windows 10, and it's like, when I saw this, when I turned the thing on, it's like, you know, and it even does that kind of weird Windows welcome screen thing, and I'm like, wow. Yeah, I really am out of date. Maybe I shouldn't even be doing this. I'm so far out of date, it really hurts. Right, so, okay. That's where we're at with this BMS thingy. Well, actually, that's really not. That's where we're at with Batman. But it is a dynamic duo, so I think we should have a look at the boy blunder. Don't go away. Alrighty, so I decided to stick my little Saley logic analyzer onto that Batman header. It's just a little simple 8 channel one. I think I won it in a competition a few years back. and it, you know, is actually able to grab that and churn out this 84.4F that we were seeing on the oscilloscope, and then the other zeros. So it looks like we probably don't need to go for full crazy gear to be able to read that. So just having a look there with this. It's been years since I've used this thing, but I was well impressed that it was able to I don't know what I'm doing here, but yeah, I was quite impressed. Just basically tell it the enable, mostly MISO, I don't know which is which, and the clock, and you just hit it, and it just basically grabs it, and yeah, seems to be able to decode it. Now the only thing is I'm not 100% certain of here, if we look at our settings, is whether we should be least significant or most significant bit. Now it says most significant is the standard. I left it on 8 bits per transfer, and clock is high when in active, and data is valid on clock leading edge. So if you do that, that basically flips our, you know, our data here a little bit. So I don't know which it is, but I guess we just have to play with that to find out. So okay, let us go and have a look at let's go have a look at Robin, the boy blunder. I suppose it would help if I had the mic on me, wouldn't it? Nothing like professionalism. Okay, now, so we have now got the scope on Robin. So we got our, let me see here, so I'm going to run that. And that is doing nothing, so I must have screwed up somewhere. What have I done now? That's, ooh, okay, maybe I haven't screwed up too much. Okay, let's slow everything down here a bit, because this is, okay, let's see what we got going on here. Talk to me, goose. Okay, Mav. This is weird. So this is old Robin here by himself. What are you doing, goose? Hang on, let me just pull something into the middle here that we can see. Okay, I've got a burst of data on the analog side here. But that is not, at least that I can see here, responding to anything. Have I screwed up here? Oh, I have. Hold on. I think I've screwed up wiring up the probe here. Have I? I did, yeah. Sorry, folks. I'm a bit of a muppet at the minute. I've got my ground. Yeah, I'm going to put another line on here because I think I'm screwing up the. I think the reason we're not seeing anything here is I've screwed up on the wiring up of the probe header. But hang on, that doesn't make a whole bunch of sense. Like I said, you can have a smart scope, but a moron running it doesn't help the situation. Actually, hang up. The last vestige of the moron being the auto scale. Let's see what it makes out of that. Nope. Doesn't like that. See? This is it. Okay, everyone chill out for a bit. I'll see if I can fix this. yeah, so it's kind of like I said, smart scope, idiot running it. But it is definitely a different kettle of fish going on here. What seems to be super strange is that the analog signal is not necessarily in tune with this. Now, this is fascinating stuff, folks. I know you're probably fascinated too, right? You probably had all of the fascination that you can probably get at this stage in the game, I'm sure. Let's move this over a bit, see if we can make some sense out of it. What do we got here? Well, we're definitely getting clock trains, and we're getting data by the look of it here, but it's odd. Ooh, hello. Hello. Do you mind calling in for a chat there? Here we go. Okay, so it looks like we're getting some kind of bursts going on here. Here we go. Let's pause you and see if any of this is making sense. Of course, the other thing we need to be aware of is that we've probably not gotten any of the right loading on this thing that we're supposed to have. Oh, what's this? Hello. Okay. Well, ain't that a blast? Is it using zero crossings for the clock? Don't know. Let's try something. Yeah, this is probably going to be a really bad idea. So, what happens if we our probe down here on this guy? What happens if we what happens if Damien grows a brain? World will end. What happens if we really? Seriously? Connect them. Oh, Gordon Bennett. I mean, this is amateur hour. How can I possibly publish this with my usual finesse? Do you know what I'm going to do? I'm going to rob 2 cables from the next demo that I'm going to be showing you on the drive unit, and we'll yeah, let's do that, because I'm just going to muppet this up completely. Not that I don't muppet things up some of the way, but let's not muppet them up completely. Okay, so in order to avoid muppeting things up completely, got myself some croc clips here. This will probably cause it to blow up, so hang on to your butts, as they say. Let's connect these to these. This one to this. Yes, what could possibly go wrong now? Let's see what it's doing now, shall we? Yeah, that's driven it nuts, alright. Wow. Yeah, it's definitely doing some weird stuff. I mean, that's probably not a particularly scientific or engineering-y way to say it, but it's definitely doing some pretty weird stuff. Curiouser and curiouser, folks. Idle state? Don't know, but we will find out. So, alright, this is probably enough of the boring SPI messing. Let's go take a look at the drive unit. Okay, well, now that I've given up trying to get rid of you all with the BMS stuff, let's see if we can make a motor spin. That's got to be more fun. Wow. Look at that, folks. You saw it here first on my crappy channel. One motor turning, courtesy of our Model 3 inverter and our open inverter logic board. Look at that. Now, you might reasonably say to me, well, that ain't a Tesla motor, Damien. And yes, surprise, surprise, it's not. But reason we want to do this is to prove that we can fire our MOSFETs, not IGBTs. These are MOSFETs, silicon carbide MOSFETs for that matter. That we can fire them in the appropriate way to generate the correct pulse width modulation to make three-phase AC, and indeed we can. So what we've got here is we are currently running the PWM from the logic board up through this ribbon cable into our little breakout board and into the gate driver chips. Elon's brain here is held in reset, so all of the pins on that chip are high impedance, so they don't mind me firing my own signals in. It's basically in a coma. So probably the hardest part of the whole thing is getting the gate drivers worked out. So we're going to be looking at the current sensors soon. We got to do current sensors, we got to do resolver exciter, and then we just pick up here a bit of CAN and some I/O, and we'll be ready to design a board to go in here. So the way that I'm still leaning at the minute is a little kind of a board, probably about yay size, that'll basically sit in here. And we'll then wire that to the relevant points on the existing PCB, while obviously taking a wire from the reset pin on the stock microcontroller to ground, so that can not interfere with our cunning plans. So yeah, that's where we're going at the minute, guys. We're keeping myself busy. So can't complain that I've got lockdown blues or anything like that. So that's kind of it for today's kind of video. As I said, I've been kind of feeling a bit weird today. I didn't really want to do anything and yet ended up doing quite a bit. So yeah, hope you've enjoyed this one. We will be back soon. I guess I'm probably going to crack on with the inverter here, and then we'll see if we can get one of the battery modules plugged into this high voltage controller board here to see if we can figure out some more of that data. Also probably going to get one of those LTC 6820 chips and see if it'll talk on the bus here just for fun. Plus I've got a lot of reading to do about SPI and ISO SPI and all this. I mean, the inverter stuff here is pretty much bread and butter for me. So I figure I gotta keep the few gray cells that I still have working. So, all right, I'll finish there. Don't forget to dislike, do not share, and unsubscribe if you find yourself subscribed for some weird reason. Check the links in the description for pretty much the usual suspects these days. Patreon, PayPal, GitHub, Open Inverter. And yeah, that's kind of it now. I'm going to stop. So, until next time, this is going to be a happy motor spinning and happy weirdo SPI decoding thingy.